Hi guys, Rajiv here. In the previous video of this series, we learned about the working of topological sort and saw few of its real-world applications. In this video, we will see how to implement a simple build system, which is one of the applications of topological sort. But what exactly is a build system? In simple terms, it automates the building of a software which might get complex. A project may have many dependencies which needs to be resolved before the main program compiles, and in correct order as well. All the dependencies needs to be compiled and then linked together to form the final output of the software. This is a tedious job, which we will see how. One thing to note is that the order of execution matters in all of these things. We cannot compile the main code before its dependencies are met. Let's understand this with an example. Suppose you have a web app which you want to deploy, but before deploying you want to test it. And your project might be having dependencies on any external libraries or any sub-packages that you created, and you want to bundle them. Before bundling, you want to test each of the dependencies. Let's also add dependency 3, which is a dependency for dependency 2. For the final deployment, the execution order of each of the steps matter. It can be either this or this, but from both steps we see that dependency 3 is compiled before dependency 2, and also for bundling, each of the dependency is compiled before the bundling dependency step. You might be saying that these steps are fairly simple and can be done manually, but no, we are human and we make error. When we run this program and at time after making some code changes, we might miss few things and we deploy a faulty program. Even if you are not convinced, let's move to the next example. Let's say you want to build a game, and for all the three platforms, Windows, Mac and Linux. And for building the game, you need a Windows system for creating windows on the platforms. You also need a graphics engine for both Windows system and game app. And then we need listener objects for all the input devices, keyboard, mouse and joystick, which would be inheriting from the same input class. Then we also need sound system for better user experience, and then also we need graphics driver for hardware accelerated rendering of the objects. We can see this is quite a complex project, and the order of execution of each of these steps matter. We cannot compile Windows system before compiling graphics engine, or let's say we cannot compile graphics engine before compiling the drivers API. Also, we cannot compile Windows system before compiling each of the listener objects like keyboard, mouse and joystick. One of the order of execution for compiling the complete game for all the three platforms are: firstly we need to compile GPU drivers, and then we compile the graphics engine, then we compile sound system, then we create the input listener class, and then compile each of the listener objects for each of the input device. Then only we compile the Windows system. Finally, when all the dependencies are met, we compile game app for each of the three platforms. For this video, we would be developing a build system and then test it on this graph or on this project. At first it may look intimidating, but let's just change a few things. Each of the nodes here are a Python file, and their sole job is to generate a text file, and their content could be the name of the file itself. But any of the node cannot be compiled, or can be compiled only with errors before their dependencies are met, before all their dependent text files are generated. Let's say d.py cannot be executed before b.txt, a.txt and c.txt are generated, and that can only be generated if before d, b, a and c.py are executed. For our build system to work, we need some configuration files like makefile or maven, etc. In our case, we have used a simple JSON object in which each key means the task, and then it has a value of an object, and then the object has two attributes, dependency and command. The dependency lists out all the dependencies for that task, and the command is the command which will be run when that task is executed. For example, A has dependency on B, C, F, G and H. Similarly, D has dependency on BAC. Now we need to convert this configuration file into the graph format that can be used with the topological sort function that we have written in the previous video. Here each of the tasks is inserted as a children of each of its dependency. For example, B is dependency for A and D. Similarly, D is a dependency for J, K and L. That means D is the parent of J, K and L. Similarly, F, G and H are children of I. That means F has a dependency on I, G has a dependency on I and H has a dependency on I. What we need to do, we just need to add the current task as the children of their dependencies. Now let's see the Python 3 implementation for the same. Firstly, we load the build.json, which is the configuration file for us, and then we create a dictionary using it, which we call bsystem. Then we create an empty graph with the keys as all the tasks present in the build.json, and then assign each of them as an empty list. Now we iterate over all the key value pair for all the tasks in the build.json, and then for each node or each task we extract the dependency list, and then for each dependency we add current task as their children. For example, for A we move to B as the first dependency, and then for B I add A as B's child. Then after the graph is created, we pass it to the topological path function that we created in the previous video. It just creates a topological sort order of the graph that we created, then returns a list of the tasks in the order which it needs to be executed. Finally, we iterate over all the tasks and then run the command which is present in the configuration file using os.system. Now let's see the demo. Let's start with the implementation. First, let's create the configuration file, the build.json, and create the dependency configuration for the same graph or the project that we saw in the video previously. For example, A has a dependency on B, C, F, G and H and all the things. It is same as the graph that we saw earlier. Now let's load the configuration file. For that we need OS and JSON package. Now let's load the build.json in our project, then create an empty graph. Now let's iterate over each of the key value pair and then create a graph for our JSON file or the configuration file. Now let's check whether our graph which is created is fine or not. Let's try running it. This graph looks exactly the one that we saw earlier in the video. Now let's pass the graph created into the topological path function that we have created earlier. Let's remove this print function as well. Let's check whether this graph is fine or not. Let's check the output. Oh boy, the output is correct. Now let's create the final piece of the code where we would be iterating over each of the tasks in the topological sorted order and then execute the command which is mentioned in the build.json file using the piece of code. It would iterate over each of the sorted node and then using the dictionary for that node it would call the command. But for testing this configuration we need these a.py, b.py, c.py and so on. We discussed earlier that the sole purpose of these Python files or programs are to generate a .txt file with the content as the name of the task it has been created with. So a.py would generate a text file which would have content as A. Similarly, b.py would generate a .txt file with the name as B. So are we going to create all these Python files manually, all these till L? No, we are computer science students, so we would be using code to create such files, because all these files have same structure except the output name. So let's see how a.py would look like. a.py would have a name as a. It would load the JSON, the build.json file, to just get the dependencies for that particular task, which is referred by the app name. Then finally we iterate over each of the dependency and load the .txt file created by them. By them I mean the .txt which is created by the dependencies of the current app name. Now we append the content of each of the text file, dependency text file, to the current output. Now we create the output for the current file, which is a.py, using this. We observe in this that only this would change for different file. So what we can do, we can create a script and then generate file for each of the tasks present in the build.json with the content as same, but this name value of the app name has changed to their task name. So what we can do, let's just create test files .py. Here let's import the build.json so that we could get the name of all the tasks that are there. Then let's create an output template. Here let's just paste the a.py's content and then put the curly braces instead of a, so that we could replace it with the name of the task. Now finally let's iterate over all the tasks and then create a output.py with the same content, but this has changed. Now let's try running it. We see that all of the py file are now created. For G, we see G is there and then all of the content is there. Now finally let's try running our code, the D-Day. Let's check if it runs or not. Oh, it is running. We see it is running in the same exact order as the topological order. This won't work if the dependencies are not met earlier. So let's check that as well. For that, let's first reverse the order so that we are deliberately making it run a different path, and also let's remove all the txt file which are created with the previous build. Now let's try running it again. We see the error is coming up. We see here that for g.py i.txt is missing because i.txt has not been run before the g.py. We see I is running at the end, so it would give error. Let's check it again with the correct code. Before that, let's also remove all the txt file generated so that we have a clean project, and then start the run for the build.py. Yes, this is the output that we wanted. Pat your back. We have created a simple but yet powerful build tool that can be used even to build a complex project. Show me how you use this build tool with your projects, or even make your own build tool. I hope you enjoyed the content. I will see you in the next video. Thank you.